All right, so this function notation replaces what would normally be a y in an equation, right? And this should be at the top, by the way. So function notation. So instead of y, we could use an f of x, okay? So what this is not f times x, okay? It's not multiplication. Everybody clear on that? I swear to God, if anybody goes to solve one of these things and like they divide both sides by f, I can't even, just, no, all right? It's not f times f. It's read f of x, okay? Or,
Not of plus times.
all right, but this is just notation. This reads f as a function of x. F as a function of x. Okay? So in other words, it still is that you put x's in as an input, right? And the output is now f, like instead of y. Okay? What's that? 179, 3.2. Okay? It is not multiplication. Should have left more room. It's not multiplication. It just replaces y. Okay? And it doesn't always need to be an f. That's like the generic one we always start out with, is f. You know, function starts with f. It could be a g, it could be an h of x, right? It could be an h of t. We're using like time as a variable, right? Where you input a time, right? And the output is like a height of a ball or something like that, right? So it is not multiplication. It's just read f as a function of x. And the shorthand of that is just say f of x, okay? So let's go back up to the top here. And here's how it works, okay? So this, read this to me. What does that say?
Of x equals
No.
f of
F of x
x
equals,
3x plus 7.
so f as a function of x, right? Like this depends on what x you put in, right? Okay, so that's what it means by as a function of x. So you put x's in, and out comes the value of f, right? So if you see this here, see this now instead of f of x, what does this say? F of 2. So this x got replaced with a 2, didn't it? So what that tells you is everywhere you have an x in your equation, you replace it with a what? A 2. So now we can say, here's what f of x is. F of 2 would be 3 times 2 plus 7. Right? That's all it is. And so we're just substituting like we would if it had been a y. So that's 6 plus 7, which is 13, right?
Is f like that just be like a variable for
F is not a variable. F is just the name of this function. So it gives your whole equation a name instead of just y. When you get into, say, like physics or chemistry or something, you might be dealing with two different equations or functions in a given problem, right? And so you might call one of them f of x and the other one g of x. Do I get right? To know which one is which. So it's a little more useful than using a y. Okay, what does this say right here? Everybody. F of negative 3. Is that multiplication? No. So wherever we have an x, this tells us to replace it with negative 3. That's all. So 3 times negative 3 plus 7. That's negative 9 plus 7, which is what? Negative 2. Okay. Read this one up here, B. Everyone all together. What does that say? G of x equals... Okay, so this function is just called g now.
What? Where does the negative 3 come from?
Anywhere. It's just a random example.
If the number isn't an x, 3x.
Where did that come from?
Yeah.
They just put it there.
But it was 2 and then it just came to negative 3. Where did it... Why did it's an example.
Yeah, you could put, the point is you can put any number you want. In other words, here's our function f of x. And you know that you can input any value you want for x, right? This just tells you which one to input, that's all. And you like any real number you can put in there. So g as a function of x, or g of x, right? So g of 20, we just replace that x with 20, right? That's all. 20 minus 6 over 2. 20 minus 6 divided by 2. 7.
I was in this.
Sure. G of 0. All right, so we just do 0 minus 6, wherever there's an x, right, over 2. That's negative 6 over 2, which is what? Negative 3. So really what this says is g as a function of x when x is 0. Or g is a function of x when x is 20 in this case, okay? So just a more useful notation to use, especially if you go on to like science or engineering or that kind of thing, okay? I'm going to let you guys do the last one there. That's h of x, okay? Do what now? That's just a square root, right? Just do order of operations. The square root kind of acts like a grouping since you got the stuff inside first, right?
Wait.
So h of 4 would be square root of 2 times 4 plus 1, right? Go ahead.
So what
Oh my god. Not the square root.
You'll do the square root part last. It's the opposite of square root. What's 3 squared?
I don't know.
3 times 3.
9.
Oh, alright.
9. So the square root of 9 is 3. They don't go square. Talk about that.
How do we
What's 5 squared?
take a new village
So
of
that-
town?
That's fine.
Which is 25, yeah. So the square root of 25 then is 5. Yeah. So what'd you get for h of 4, kids? Yeah. So that's 8 and 1, 9. Now, be careful, listen. I don't know if you've ever been told this. Whenever you take the square root, you get 2 answers. It has to do with what we were talking about there, right? Just a minute ago. Why would that be? That's read plus or minus 3. Okay? You do know that 3 squared is 9, right? What's another number you could square and get positive 9? And get positive 9. Negative 3. Don't you, bless you. Don't you also get positive 9 when you do negative 3 squared?
That's fine.
That's plus or minus. That's a symbol for positive and negative 3.
That was
So you
confusing.
got 3 because 9.
The square root of 9 is 3. The square root of 9 is also negative 3. Because what's negative 3 squared? What's negative 3 times negative 3? Positive 9. So the square root of 9 is also negative 3.
The
Right?
bottom one is
Now, a lot of times, we're only going to consider the positive square root, right? But just so you know, whenever you take a square root, there are 2 possible answers to a square root. The positive and negative of the number. Because when you square the negative version of it, it becomes positive as well. Okay. Do h of 0. Square root of 2 times, 0 plus 1. That gives us a square root of what? 1. And what is the square root of 1?
1, negative 1.
Plus or minus 1, right? 1 squared is 1. Negative 1 squared is also 1. So plus or minus 1. What's 1 times 1? I'm just working the square root backwards. What number do you square to get 1? Right. What number do you square to get 9? So, yeah,
Yeah, but then how'd you
2
get
times
9?
0.
2 times 0 is what?
Isn't it 2? Oh, no, it's 1. That's
That is where, okay, now you got it
Okay,
right.
right.
Okay, now you got it, okay. All right then. All right? So, but again, most of the time, a lot of the times when we take the square root, we'll just be considering the positive. But there's going to be times when we do, we're going to have to consider the plus and minus of the square root, okay? Let's move down here. Given the function, what does that function say? All together now? Everybody?
X equals x over 3 plus 7.
Okay. So what's this rule? I mean, we've done this, right? Where we told it, okay. So just look at this part, like we did a few sections ago. What is this telling us to do first to the x? divide by 3, and then you do what? Add 7. So that's what this function rule says to do. That's all. Okay? So they want us to evaluate f of 6 and f of negative 9. So let's write it like this. We'll start over the left here. I'm going to do f of 6 here and then f of 9 over here. Okay? So f of 6, right, equals what, kids? 6 over 3 plus 7, right? So f of 6 equals, what's 6 over 3? 2 plus 7, so f of 6 actually equals 9, right? Now do f of negative 9. Over 3, I am now, yeah, thank you. So f of negative 9 equals, what's negative 9 divided by 3?
Negative 3 plus 7, and that is 4.
Right? Circle you guys. Okay? Now, in part C, they're asking us to do it differently, right? So here's our f of x function up here, right? They're asking us for what value, for which input, will f of x, the entire function, be equal to 13, right? So do you see the f of x up here? They want that to be equal to 13. They want to know the input. So they're actually asking us to do what? What's the input? X. And we know the output, so what are they asking us to do? Solve it for x, yeah, right? If the whole function equals 13, right? That means that this function, x over 3 plus 7 equals 13. Yeah? So they're just asking it backwards now, right? This is one like where they were saying, okay, look on the graph, go to the graph where the graph is 13 and go down and find the x value. So they're kind of asking it backwards this time. So what do we do here? Else, subtract 7 first, reverse PEMDAS. So x over 3 equals what? 6. And now what? So you get an x of what? 18. Okay? So again, this one was backwards, right? And the other ones, they were telling us what to plug in for x, right? And this one, they're telling us, well, the function is going to equal 13. What x makes that happen? So you just solve for x, that's all. Okay. Now, part D is a little bit different, okay? Yeah. So remember, if you look at part B, it was pretty simple. Should be a spacer, huh? So we have what f of x is equal to, right? And if they wanted f of 6, what did you do with every x? Replace it with a what?
Number.
6, right? If they wanted f of negative 9, you went back to the function and replaced every x with what? Okay? They could ask you for f of anything, right? They could ask you for what's f of squirrel, and then every x would be replaced with what?
Squirrel.
Squirrel, right? Yeah, okay.
What's squirrel?
Nothing, it's just, I'm just illustrating the extremes of thought of this with an absurd example. Okay. So, now we have a new function. What's this new function called? G of x. And what does it equal? 2 times the function f of x minus 1. And they want to know what is g of 6. Well, we don't really even know what g of x is, do we?
No, but it's g of 6.
But g of x is, see this right here? So wouldn't I replace this with f of x to see what g of x is? You follow me? So let's figure out what g of x is, then we can get what g of 6 is. So g of x, let me go over a little bit. Keep some room. G of x equals 2 times f of x. What's f of x? X over 3 plus 7. And then minus 1. Right? So I just replaced f of x with what it's equal to, right? Okay? Bless you. All right, so let's simplify this out here. So g of x actually equals what? No, not yet. Distribute the 2. 2x over 3?
I don't know what's going on.
No, 2x over 3.
Oh.
Or 2/3 x, right? Plus what? Plus 14. And then minus 1 on the outside. So let's clean this up. So g of x actually equals what? 2/3 x plus what? 13? Can we follow that? Where did I lose you? So they just told you what g of x was in terms of f of x. That's all. G of x just says, well, what's g of x? Well, take f of x, this thing, multiply it by 2, and then subtract 1, and that's our new function g of x. Do
How
what?
do you get the 2 over 3x?
2 times x over 3.
2 times x.
2x.
So x over 3, you agree you could write it as 1/3 x, right? Isn't that the same? 2 times that, you just, right? Multiply across the top, 2 over 3 x, right? Okay, so now we know what g of x is. Let's get g of 6. So g of 6 would be what? 2/3 times what?
2/3 times 6.
6, yeah, 6 times there. Plus 13. Okay, do 2/3 times 6. Remember, top number's multiplied, bottom one's divided. 4, right? Plus 13, which is 17. Okay? Function notation is just a new way to replace y's. But do you see how, like, when you replace y, this is a more flexible notation to use. You can do some other stuff with it. Okay? Well, just wait. I don't want you to miss the notes here. Okay? Just hang tight. Okay? Let's go to the other page. What do we got going on here? So here's a different way to display a function. So we can display a function as like an equation. We can also display it as a graph, right? You saw graphs on last night's homework. You've seen graphs before. Or we can also display a function as a table. Okay? So what is this exercise 3 about? Somebody tell me. Just boiling water. At what temperature does water boil, guys? You should know that. 212 Fahrenheit, right? Does anybody know what temperature Fahrenheit it freezes?
Wait, what?
What temperature does water freeze at in Fahrenheit?
0.
32.
Oh, 32, yeah.
0 Celsius
0 Celsius.
freezes at. Yeah.
I was,
Do.
get rid. This is how it's on
It's equivalent to a cell phone.
on the board.
Yep. Clock, board. It's all right. Anyway, so you got a cup of boiling waters left in the room, and what's the temperature of the room? So what do you think is going to happen to the water? If it starts out coming right off the stove at 212 degrees, and you're in a room about this temperature, what's going to happen to the water? It's going to start, the temperature's going to go down, right? And they calculate like how fast, like every minute or so, they say, okay, what's the new temperature? They put a thermometer and say, okay, from 1 minute. So at 0 minute, or hours actually, okay, this is an hour, sorry. So at 0 hours, obviously it starts at 212. After 1 hour, it's down to 141, right? You get the idea? in 2 hours, 104, and eventually after 8 hours, it's the same temperature as the room, okay? Because everything tries to equal out in physics, right? All right. So this is a function, right? Which in this table, what would you say are the inputs? The hour. So the input is the hour, and the output would be what? Temperature. Right? So, like somebody says, what's the temperature after 3 hours? You input a 3, and the output is 85 degrees. Okay? And this is read T of H, temperature as a function of H, right? So it makes sense. We're not using an X. H for hours, and our T of H. T, temperature, is a function of hours that go by, right? So they want us to evaluate T of 2 and T of 6. Well, this is not too hard. So T of 2 would be found here, wouldn't it? So that's the input. What's the output? 104 degrees. T of 6. That would be found here, wouldn't it? 68 degrees. Okay? So if you got it like a table, it's pretty, so you don't have to do any calculations, right? For your input and output. All right, go. Yeah. All right. Now, B is asking this differently, right? For what value of H input is T of H, the output, 76? Right, so now they're saying this is the output. What was the input? So, yeah, where is an output of 76? Right there, right? So H equals 4 hours. If our output is a 76. Does that make sense to you? Okay. Let's move on to the next one. All right. Between what 2 consecutive hours will T of H equal 100 degrees? Yeah. Does it actually say 100? Any of these outputs say 100? No. What? Where would you say? Between what 2 hours?
1 and 2.
So here's 1 and 2.
Never mind.
Okay. So hours 2. So between 2 and 3 hours, right? 2 and 3 hours. So somewhere in between there, right? Okay? You'll go from 104 past 100 and end up at 85. Okay? How'd you arrive at your answer? Just between these hours, what does the temperature do? From what to what? Between these hours, yeah, the temp drops from what? Yeah, from 104 degrees to, what was it, 85? And of course, 100 is in there somewhere, right? Okay. So that's a tabular representation of a function. First page, we're looking at equation for our function. This is a table that represents our function. And there's another way to do it. It said how? Graphically, right? Okay? So you notice this graph has different straight line segments to it. It's in pieces, it's different pieces, right? It has different sections, right? Anybody know what that's called? It's a piecewise linear function, right? Because other than like a straight linear function, the line just never changes direction or anything, right? This has different pieces of the line that will change their slope, right? Okay? So this is our function, right? This is our f of x function, right? This is f of x, that whole graph, right? And what are my inputs? Where do I find my inputs? Right, these are the inputs. And I should replace y up here actually with f of x, right? Because I said you can do that. So sometimes you'll see your graphs now with an x-axis and instead of a y-axis, they'll call it an f of x-axis, right? unless your function is g of x or whatever, okay? Okay, let's evaluate f of 1. So that's an input of 1. And then you go to the graph. F of 1. What is the output? Goes up to 4. Right? Okay, you guys take a second and fill these out. Do f of negative 3, f of 5, and f of 0. Okay, what's f of negative 3, everybody? What is it? Negative 4. Yeah? So let's go to f of negative 3. Go to negative 3. 1, 2. Here's negative 3. And the graph is down here at negative 4. Right? Huh?
I did.
Did you do it backwards again?
No, I did it right.
Good
Sorry.
Yeah, hurry up.
I was at negative 2, not negative 3.
Oh, just gotta, yeah, just be careful counting. How about f of 5? Negative 2 and f of 0. Positive 2. There you go. Okay. Now they want us to solve these. Good. It's going to be easier because we don't have an equation to work through, right? Now, it says the function itself here equals 0. F of x equals 0. Okay? Right, now remember, you're measuring the function on the y-axis, right? So find on the y-axis where this function equals 0 as we count up and down. Are there more than one spots? Is there more than one spot?
Oh, yeah.
Where the function is 0? Let's circle. Would this be a spot where the function hits 0? Right? 0 up and down, right? Okay, it's not 0 on the x. And there's another one. And here's another one, right? Okay. So f of 0. The first one is found at where? X equals what? Negative 1. And then you need the word or. X equals what? What's the next 0? X equals 4. And then the word or, not and. X equals what? 7. Okay? So there's basically 3 solutions to this, isn't there? Okay? And when you have this, you use the word or. Why do we use the word or, not and?
Because and is you're only including one, not adding, isn't it?
No, because
only one has to be true.
right. Well, only one can be true. In other words, a variable cannot take on more than one value at a time. It can't be all of those things at the same time. And would mean that x is 1 and 4 and 7 all at the same time. It doesn't make sense, right? So you always use the word or when you have more than one solution. Okay. All right. So over here, they want where the function is equal to 2. So let's find out where the function is equal to 2. Would it be there, right? Counting up. Is there another one here? Is it equal to 2 anywhere else? It's not. Okay, so what are those x values where it's equal to 2? At x equals what? 0. Well, what 3? What did you say right before 3? Or, yeah, x equals 3. Okay? All right. So, what's the largest output? Remember, the output is the f of x to y value, the graph,
7 and 3.
achieved by the function. There's an output of 7.
3.
What's the largest value that graph hits?
Oh, 4.
It's right up here, isn't it? 1, 2, 3. It looks like 4 to me. Yeah. So f of x equals 4. That's the largest value, the maximum value, right? At what value? At x equals 4, right? So what can we say about that? So f of 4, is that x equals 4? No, it's x equals 1. Sorry, guys. Why did I put a 4? I did. 1. That's a 1 right there. So f of 1 right? So f of 1 equals 4. That's what I'm trying to say. Jeez, yeah. That makes sense? A little bit. So it's not like a whole lot new here except just the notation, guys. That's all. Like knowing that the x-axis are your input values and the graph are all the output values. We've done that already, right? The only thing new here is the notation. It just gives us more flexibility. Okay, let's go do some Regents questions. Number 183. I think these will be fairly straightforward. And remember, where else do you get to see these Regents questions? That's pretty important. Yeah, well, now you won't see these again in the Regents, but where will you see these questions again? On the test, right?
Oh.
Okay. So, I want everyone to read this first one. Think about what we were just doing. We gave you a function f of x. I want to know f of 2. So what does that mean to do? Yeah, so we're going to do that right now. Tell me what you got. And show the, do not go like substituting things in to see if it works, okay? So f of 2 equals 2 times 3 to the 2. You got number 1?
So I turned that. I would turn both the x's into 2.
Well, she means you have like the
Wait.
right the plug, yeah,
So
but that.
once you're done like multiplying 2 and 3, you add
What do you do
your
first?
exponent first.
Yeah.
And then Sakari's not bad.
Oh yeah, wait, you gotta wait.
But what do you do? Like, would you put?
PEMDAS.
You do your exponent.
Yeah,
and then you
PEMDAS.
apply-
PEMDAS.
Oh, parentheses.
We can't do the multiplication first, can we? PEMDAS.
But there's parentheses.
Okay, is there any work to do inside the parentheses?
No.
Right. So then you go from the P to the E. So it's 2 times what? Which is 9. You don't multiply first. Yeah. So what does f of 2 equal?
18.
18. Which is... Oh, is there a plus 1? Okay, sorry. I thought that seemed kind of funny.
So 19.
19, yes. Okay?
I don't, where does the 2 come from? That's where the x of x.
They said to put a 2
Oh,
in.
okay.
That
So
right?
what about the x of like the 3 is? Yeah, where is that? What I just put the 2 right there.
Yeah, that's it, right. So this said, so if f as a function of x is that, and they want to know what is f of 2, that means wherever there's an x, you put a 2 in it,
Oh, okay. That's all.
right? Yeah, yeah. All right, let's move on to number 2. Okay? I think you guys are getting this now, so I want you guys, I'll take a minute. And by the way, you see how my math works here? That's what yours should look like. No more of this scattered crap that I see, all right? So everyone take a minute on your own and do number 2. So you'll have g of negative 2 is going to be negative 4 times negative 2 squared minus 3 times, look, put a negative 2 in there, plus 2, right? Okay, somebody said, what, 24?
I got negative 8.
We got 24, we got 8, we got negative 8.
Negative, so you have to write down negative 4, parentheses, negative 4.
No. Negative 2 squared is what, everybody? Positive 4, right? You gotta stop doing that. What's next? Plus 6, plus 2.
Yeah, but
Yeah?
what do I do? Add the 3 and the 2 together?
No, that means to multiply.
Negative 6.
Right?
That's 2.
So negative 16 plus 6 plus 2, right?
Negative 4 times 6.
So it comes to negative 8.
It's not negative 4 times negative 4. It's negative 4 times 4.
Yeah, that's a
Oh,
positive
that's what I
4.
meant.
Guys, when you square a negative, it becomes what?
Positive.
Positive. That's why there's 2 answers to every square root. Right? All right, moving along. Hey, this is kind of the same thing, isn't it? Yes, ma'am. Hold on. Everybody a chance. Well, do another one. It'll probably be less complicated.
Yes, that is getting more complicated.
This is actually less complicated. So that is negative 12, right? Plus 5.
Oh, that's, I put.
Yeah, well, guys, you got to picture your number. If you're on this side of 0 at negative 12, and you add 5, you're coming back this way, right? To negative 7. And this is how your work should look, guys, right? See how mine looks? That's what yours should look like. Yeah, go ahead. All right, the rest of you, move on to 4. Hey, look at that. It's another function. I want to know g of negative 3. Not really any different, is it? So go ahead and work on this one. And, oh, please, God, when you swear a negative, what do you get, people?
Positive.
Thank you. And do you square first or multiply by negative 2 first? Thank you. Okay.
I won't do that.
You have to, that's just like the basic thing. You got square negatives. Exponents come before multiplication.
I got negative.
Negative what?
Not an answer.
What was your answer?
Negative 21.
Nope. What's the matter?
What do you mean that you were squared? Like,
What's negative 3 squared?
what I do, like, 3, 9,
What's negative 3 times negative 3?
9, what's 3?
No.
9.
You're trying to take the square root right after it. Negative 3 times negative 3 is positive. Look, up here. See that right there? It's kind of the same thing, right? It's negative 2 squared. Positive 4. So negative 4, right, still times that.
So I just put 9 as a...
Yeah, because that's what negative 3 squared is. Exactly.
Yes, but then we're going to do the 2.
Well, after you do exponents in PEMDAS, then you do multiplication.
Yes, but I got negative 18.
So? Is that a problem? It's a number 2.
Yeah, ever always big numbers. Too many numbers.
So G. What did you get?
Negative 27.
You got positive 27?
I got
You
negative.
got negative 27? Anybody else? What'd you get?
Negative 27.
It's negative 27.
No, that's what I got now.
That's true. So this would be negative 2 times 9. What? Minus 9? Right? So G of negative 3 equals what? Negative 18 minus 9. And what is that?
Negative 27.
Negative 27. No, you're not multiplying them. No, you're trying to do, when you multiply 2 negatives, yeah. Now, when you're adding and subtracting, you're just moving left and right on the number line. It has nothing to do with the multiplying, right? Because if you're starting out, look up here. Here's 0 on your number line, and negative 18 is down here. If you subtract 9 more, you move further down to negative 27. Okay? All right, moving along. All right, I got another, I think you guys can do the graphical ones, right? You just did them in the notes.
I don't know how to do.
What are your inputs? Where do you find the
So
inputs?
we skip the graph.
Where do you find, no, where do you find the inputs? On the x-axis. Where are the outputs? On the graph. So there's f of x, just does this. That's actually a cubic function. That's something x to the third.
Oh, but yeah, this is.
But anyway, you don't need to know that. So they want f of what?
3.
No, negative 3. So where do you find
It's
negative
6.
3? On the what?
It's 6. On the x.
X-axis.
Go back negative 3 and then you go up. Okay.
So input f of negative 3, 1, 2, 3. No graph, well, I guess it's up here. So we go 1, 2, 3, 4, 5, 6. F of negative 3 equals, did we get that?
Yeah.
You really want to skip the graph? Isn't that easier than solving the equation? Right? Stable? Okay, moving along. Now remember, these ordered pairs are x comma y, right? Right?
Yes.
But what do I say we replace a y with? So you can think of them as just x comma f of x, if that helps, right? It's still input, output, isn't it? Okay? Is there a key word in this question?
Not.
Not. So this is one of those annoying ones that really drive me nuts.
I hate the not one.
So you're going to have to test them all out, right? But just real quick, if you're going to test 0, comma 4, where do you put zeros? In for what? In for the x. And where do you put the 4? In for f of x. Right? So to check this, so my f of x should be 4, needs to equal 0 squared minus 3 times 0 plus 4. And you got to check that and see if it's true. Is it? What's 0 squared? 0. What's negative 3 times 0? And, okay, that makes it true. Is that our answer?
Yeah.
No. It's not, right? So you got to check. You see how to check it now, right? If you're going to check this one, what goes in for f of x? 1.75 and 1.5 goes in. So you might need your calculator for this one for sure, right? Okay, everybody take a minute and figure out which one is not a solution. Anybody get what they think is the right answer? What? What about number 2? Let's test it out. So 1.75 needs to equal 1.5 squared minus 3 times 1.5 plus 4. What's 1.5 squared, guys? 2.25 minus what? Negative, what is it? Oh, you said 4.5. No, you mean negative 4? Or negative 4.5? Okay. Plus 4? What do you got? What's 2.25 minus 4.5 plus 4? Was it? 1.75. So that violates the not part. All right?
Remember 3,
Mm-hmm.
14 equals 24.
Equals what?
24.
Right. Does it?
No.
So let's see, 14 needs to equal 5 squared minus 3 times 5 plus 4. So 14 equals, what's 5 squared? Third!
25.
25 minus 15 plus 4, right? 5 squared is 5 times.
I was doing 14.
So 14 equals what?
It's 14.
It's 14, right?
I put 14 every time.
Yeah. Well, now the good news is you don't have to check the last one, do you?
No.
It's got to be, unless it's another screw up like yesterday, but okay. Choice 4. All right. One more. Oh, there's square roots in there, but you know how to do a square root now, right? Square root. And by the way, this will only be the positive square root here. Okay? We won't be dealing with the negative version of it. So what are you going to replace all the x's with, guys? Yeah. So k of 9, 2 times 9 squared minus 3 times the square root of 9. Let's see what we get here. Go through it then. It is choice 4. So k of 9 equals, what do we do first here, kids?
You
Square the 9. What's 9 squared?
81.
Times 81 minus 3 times what? What is the square root of 9? Anybody? Somebody else? Square root of 9?
3.
3. What's 2 times 81? 162 minus what? 9. And that is what? 153. Okay, you get the square roots a little bit now, Hannah? And you guys all know the square root is just asking what number did you square to get this, right? If it's square root of 36, it's 6. Or negative 6, right? Okay?
I don't understand.